Physics part 238. Similarly, energy transferred when a further charge delta Q is transferred is given by the area of the next strip, and so on. If the amount of the charge delta Q is very small, the strips become very thin and their combined areas are just equal to the area between the line and the horizontal axis. Thus, the energy transferred from the battery when a capacitor is charged is given by the area under the graph line when charge x-axis is plotted against the potential difference y-axis. Because the graph is a straight line through the origin, this area is just the area of the right-angled triangle formed by the line and the charge axis. Thus, EP is equal to 1/2 QV. This is the expression for the energy transferred from the battery in charging the capacitor. This is electric potential energy. It is released when the capacitor is discharged. Since C is equal to Q over V, this expression can be written in different forms. EP is equal to 1/2 QV and 1/2 CV square is equal to Q square over 2C. Example: calculate the energy stored by a 470 U farad capacitor and a potential of 20 volt using EP is equal to 1/2 CV square. EP is equal to 1/2 into 470 into 10 power raised to -6 into 20 square, which is equal to 0.94 joules. Now it's your turn. A camera flash lamp uses a 5000 U farad capacitor which is charged by a 9 volt battery. Calculate the energy transferred when the capacitor is fully discharged through the lamp. Capacitors. The simplest capacitor is an electric circuit consists of two metal plates with an air gap between them, which acts as an insulator. This is called a parallel plate capacitor. The figure shows the circuit symbol for the capacitor. When the plates are connected to a battery, the battery transfers electrons from the plate connected to the positive terminals of the battery to the plate connected to the negative terminal. Thus, the plates carry equal but opposite charges. The capacitance of a capacitor is defined as the charge restored on one plate per unit potential difference between the plates. The capacitance of an air-filled capacitor can be increased by putting an insulating material such as mica or waxed paper between the plates. The material between the plate is called dielectric. In a type of a capacitor known as electrolytic capacitor, the dielectric is deposited by an electrochemical reaction. These capacitors must be connected with the correct polarity for their plates or they will be damaged. The circuit symbol for an electrolytic capacitor is shown in the figure. Electrolytic capacitors are available with capacitance up to about 1 millifarad. Factors affecting capacitance. As stated previously, the material used as a dielectric affects the capacitance of a capacitor. The other factor determining the capacitance are the area of the plates and the distance between them. Experiment shows that the capacitance is directly proportional to the area of A of the plates and inversely proportional to the distance D between them. Putting these two factors together, C in relation to A over D, for a capacitor with air or a vacuum between the plates, the constant proportionality is permittivity of free space, that is C is equal to E0 into A divided by D. Since C is measured in farads, A in square meters and D in meters, we can see that an alternate units for E0 is farads per meter.